All right, so we've used our data to make all of these summary values, and we're going to, in this video, compute the z-scores, the percentiles, and we're going to make a box plot. So we're going to go ahead and start with the box plot, keep it in the same order that you see it in the notes. And what we need to do for a box plot is to choose the data and insert a chart. Now, which chart? It's going to be under this histogram button, the one we used for the histogram, that same button. We're going to use that for a box and whisker plot as well, right? So you can see here that we can even change this layout. So fun, right? So this is what we would call a vertical box plot. You've got your lines for your mean. So the X, Excel does it a little bit differently. Let's see if we can see it better. Yeah, no, all these colors are kind of rough. There we go, sort of. All right, so remember to change your chart title if you're turning these in. But we've got our data here. The outliers, there aren't any super outliers. Excel automatically does the modified box plot version. If there was an extreme outlier, that would show up. The median is this kind of line here. You can see the value 2903126. That is the value of the median. So you can kind of see that horizontal line. The X that's floating here is our mean. And we've got our two tails out to our extreme values, right? Now, you would, again, need to change the title, but we've got our box plot here, right? So now I've got a box plot for my data. Oh, great, right? I don't know if you want to change colors or titles or axes things you might want to add. I would suggest probably adding an axis label. Just because this is the 2018 salary, right? Just little things like that that make your plots as understandable to the people that are looking at them as possible. Now, what is the definition of the z-score? We'll move on and do that real quick. The z-score is defined as the value minus the mean for our data series divided by the standard deviation, right? So we want to take, and again, we want to lock these in so that, because we want these values to not change as we drop down, but we do want this one to change. We're not going to hit the dollar signs, right? So our z-scores vary from minus 0.75 to 2.54. Remember, these kind of give you a general idea of the location of the value, right? You know that this z-score is very large. You can compare it essentially with our empirical rule. You know that this like the -2 to 2 values occur about 95% of the time. So being outside of -2 to 2, which this value is, only happens about 5% of the time. So this is a rare thing. All the rest of these are pretty much inside what we would expect to see. But regardless, they are giving a idea of where they are in the data, right? If these were mixed up, obviously these are going to go from, the biggest value to the smallest value because these are sorted, but if they were not, it would give you a good idea. Now let's talk percentiles really quickly. The percentiles is a function that we can look here. So, right, we want to take our data. We're going to find the percentiles of our data, and this K value, right? This K value is going to be what percentile we want to find, right? Wait a second. I can't say 20, right? I'm not doing the 20 percentile. I'm doing the 20th percentile, and that needs to be a fraction, right? So this like 0.2 kind of situation here, right? 20th. If I wanted to compute maybe the, no, hang on, let's actually get the data here. And then we will copy that here and we will say, well, I want maybe the 50th percentile. Now, cool thing about the 50th percentile is that should be exactly the median, and conveniently it is. We can do this for any percentile we want, especially as your data sets get a lot bigger, right? This is just a little more clunky because there's only 16, right? So what is 15 over 16? I don't know that off the top of my head. 94, right? There's only 94% of the values under this because that's all there is. Those are the only ones we've got. So as you can change these around, you can kind of see, this is not very granular data. I can move this a little bit and it will change, but I think that's extrapolated out between this because that is just, yep, that's got to be extrapolated. Back at our 50th, right? But we can do this for any particular percentile value we want to find, right? So what is that value? That value is the value such that this percentage, this percentile of the data is less than that value, right? So if I make $1.3 million playing basketball, I make more money than 20% of the other NBA players, right? That is where those numbers come in. All right. And that is it for our summary values of chapter 4.